Okay, let's take a look at this sneaky little number 6 related rate problems. Last official assignment that we're gonna do on related rates, and this is dealing with a cone. We have a volume formula here. It's also given here as well, and it has some trickiness to it. These cone ones do, but let's take a look. At a sand and gravel plant, sand is falling off a conveyor and onto a conical pile. It's actually creating the conical pile at a rate of 10 cubic feet per minute. That's our rate. That's a volume, cubic feet volume. So that is dV dt may be replaced by 10. That's happening all the time. That's not just part of the snapshot. That is a constant that we can rely on at all times. The diameter of the base of the cone is 3 times the altitude, and I'm going to use height for that, just because the formula has height and not A in it. So we have something resembling this, where if this is H, then D is 3 times as big as H. Now, to be honest, because the formula has radius in, we'd probably rather work with radius, and the radius is 1/2 the diameter, so the diameter is 2 of these radii. So 2 times the radius equals 3h, so radius is either 3/2 h, or it is 3/2 h, but another way we could write that is we could solve for h and get 2/3 r. And I'm really just setting this up right now because when I take the derivative of this thing, I'm going to get r's and h's, and I'm going to get dr's and dh's, and I'm going to probably replace some of those things along the way. So this is r could be replaced by 3/2 h, or h could be replaced by 2/3 r. This would mean that dr dh, derivative of this one, could be replaced by 3/2, not dr dh, dr dt, excuse me, dh dt. Therefore, dh dt could be replaced by 2/3 dr dt. And if you're clever, you don't have to write them both down, but it's no problem. It gives my brain a little bit of time to rest just working through here. So I'm probably either going to replace dh dt with this or dr dt with this. So let's get to the derivative work here, but they do say at what rate is the height of the pile changing. So we want dh dt, just a distance. We want to know what that is, and in our snapshot we can use a height of 15, which, oh, by the way, means that if height is 15, radius is 3/2 times 15, or 45/2 at that snapshot moment. Okay, let's find the derivative of this. Let's find dV dt, which we know to be 10 eventually. But sneakiness here. There's a variable. Pi's not a variable. R's a variable. H is a variable. We have to use product rule for this. So dV dt is, I'm going to need some room here. It's the derivative of the first, 2/3 pi. So let's bring the 2 down out in front, reduce the exponent by 1, dr dt, times the plain old second, plus the plain old first, 1/3 pi r squared, times derivative of second, dh dt. And now I can put in my snapshot values. For instance, I can put in 15 for h, and I can put in 45/2 for r, and for r. And I want to find dh dt, so I like this. The thing that's getting in the way right now is dr dt. I like this. I don't like that. So I want to replace dr dt with 3/2 dH dt. I want dH dt's. That's what I'm looking for. If this asked how fast is the radius changing, then I would reconsider that. So snapshot. Well, dV dt is always 10 equals 2/3 times pi. The radius right now in my snapshot is 45 halves. dr dt I'm going to replace with 3/2 dH dt, and our height right now at the snapshot is 15. Oh, my screen didn't just freeze. I think I'm okay. Plus 1/3 times pi. R right now is 45 halves, that's squared, times dH dt. And we need to solve for dH dt. And as ugly as this looks, this is algebra now. If we're really good at algebra, we got it made. 10 equals. I'm going to factor out dH dt. And yes, I could factor out a pi and I could factor out a 1/3, but I'm going to factor out dH dt. That's what I really want to get alone. So dH dt times, a little simplifying here, 2/3 times 3/2, I can't pass that up. And what I get is 45 halves times pi. The dH dt is factored out, but times 15 plus, I did not factor out the 1/3, I did not factor out the pi, I did not factor out the 45 halves squared, but I did factor out the dH dt. And if I call this star, all that's left for you, as I said, I'm going to leave some of this for you. To get dH dt, since it's multiplied by this, I need to divide that away. 10 divided by star. And then we just have to get our unit measure right. And what are they asking for? dH dt. dH is just a distance. It's not an area. So this is going to be plain old feet per minute. And this is just calculator. Okay, that should be a pretty good example of what you're doing for number 7. Not that it's going to be easy. I'm sure that some are going to need some support on it, but hope that helps.